Hello, everyone, and welcome to the Water Resources Institute's Spring Seminar Series, Catamounts, Catalyzing Change. During the seminar series, we're highlighting UVM alumni that focus on impactful water work across the nation. The series will dive into their current work as well as how they navigated their path from UVM to their current career. My name is Jessica Galerna. I'm a postdoctoral fellow here at the University of Vermont, and I'm very excited to introduce today's talk by Dr. Abby Frazier, entitled Rainfall, Drought, and Decision-Making in a Changing Hawaiian Climate. Dr. Frazier is a geography professor at Clark University and was the chapter lead for the Hawaii Pacific Islands chapter of the 5th U.S. National Climate Assessment, which is really cool. I added that in. She earned her Ph.D. and MA degrees in geography from the University of Hawaii at Mānoa and has a BA in geography and a BS in mathematics from the University of Vermont. Before joining Clark in 2021, Dr. Frazier was a research fellow at the East-West Center in Honolulu and a postdoctoral research geographer at the USDA Forest Service Institute of Pacific Islands Forestry. Dr. Frazier is a climatologist, I know it's a mouthful, who studies rainfall patterns and drought in the Pacific Islands and uses geospatial analysis to understand the impacts on freshwater resources and ecosystems. She collaborates closely with stakeholders to co-produce actionable science to support climate-related decision-making and natural resource management. She co-leads the Pacific Drought Knowledge Exchange and is a co-PI on the Hawaiian Mesonet and Pacific Research Projects. This talk will be about 30 minutes with 15 minutes of Q&A at the end, so please hold your questions until then. And welcome to our remote guests on Zoom. Super excited to have you here. If you're joining us via Zoom, you can enter your questions into the chat box at any time during the presentation. And with that, it's yours, Abby.
Thank you. Thank you so much for the introduction. It's always awkward when it gets read fully out loud. The whole thing. But no, thank you so much for having me. It's honestly really exciting to be back here at UVM at my alma mater. As was already said, this is kind of my journey. I grew up in Vermont. I am from St. Albans. And UVM undergrad graduated in 2008, so it's been a little bit. Studied math and geography, as was already said. As I was nearing the end of my undergraduate time at UVM, I was very focused on sort of how am I going to get a job? And for me, GIS felt like the most straightforward path at the time to getting a job. And I was had kind of stumbled into geography about halfway through, but totally fell in love with GIS and with my weather and climate courses. And Professor Wemple helped me secure a couple of different GIS internships my senior year with the County Forester's Office and the Transportation Research Center. But I was itching to leave Vermont after I graduated and moved to Seattle for a year. Worked as a GIS analyst, not with Esri software, but with MapInfo, which is a competitor to Esri, even though no one's probably heard of it. Maybe a few nodding heads, but so I was working with MapInfo GIS software, selling it to our clients and doing some software testing, which was not really what I had envisioned for myself, but it was really fun. And I loved Seattle. But then thanks again to Professor Wemple, she put me in touch with one of her colleagues from the University of Hawaii who needed a master's student to work on a rainfall project. And so fully funded master's landed in my lap in Honolulu, and I said yes. So off I went, did my master's, stayed for a PhD with the same advisor, and then was able to stay in Hawaii for postdoc and research jobs. And then in 2021, was able to get a fantastic tenure track job at Clark University in their geography department, which is just a fantastic department. They have the oldest graduate school in geography in the country, and brought me back to the Northeast and closer to family. But they still let me work on Hawaii Pacific Islands work, which is kind of best of both worlds. So I'll be heading back there in a couple of weeks. Zoom has allowed all of my work to continue. And so I am a climatologist. This talk is very much going to be climatology focused. I consider myself a geospatial climatologist using geospatial analysis with climatology methods. And I study climate change and work to better understand how climate is changing across spatial scales, temporal scales. I do a lot of work with climate variability. And as was already said in the bio, do a lot of work translating this scientific information for stakeholders. And I'm not going to talk more about it in this talk, so I wanted to get this out front. I spent a lot of time today talking about climate assessments, which I love, and I'm happy to answer questions. But I was the chapter lead for the 5th U.S. National Climate Assessment Hawaii Pacific Islands chapter. The National Climate Assessment is supposed to be released every 4 years. It is congressionally mandated. It is supposed to tell us the state of the science, what we know about how the climate is changing, how it's impacting things we care about in the US, and how it's projected to change in the future. So the most recent NCA 5 was released in 2023, and they invited the chapter leads to the White House for that event, which was really exciting. And yeah, I could easily spend this whole talk talking about just climate change in the Pacific Islands. For those of you who have not accessed NCA 5 before, or if you've had trouble accessing it now that the websites have been taken offline as of last summer, there is a new URL I would love you all to bookmark, nca5.climate.us. They have relaunched the NCA 5 website and all of its content. They are also migrating lots of other climate.gov resources to climate.us. So we can give a huge round of applause to those awesome scientists out there doing this work. Exactly. So bookmark that if you are interested in some climate assessment work. Okay, so let's take a step back and talk about some of the work that led me to go from, Vermont native, first generation student from UVM to leading this Hawaii National Climate Assessment chapter. So I'm going to take us all to the central North Pacific Ocean. You can see how remote and isolated the Hawaiian Islands are. Hawaii is located around 20 degrees north latitude. The state of Hawaii, these are the 8 main Hawaiian islands that are mostly populated. I lived in Honolulu here on the island of Oahu. It's the most populated island. Hawaii Island is down here in the southeast. This is also called the Big Island. All of these other islands can fit inside that island. This is where the active volcano is located. And you can see these mountain peaks in yellow. The elevation get much, much taller as you head to the southeast, right? Big Island is the youngest island, active lava. These peaks are almost 14,000 feet tall. So yes, it does snow in Hawaii. And this incredibly varied topography results in extremely complex climate patterns and climate that changes a lot over very short distances. So we get a wide range of ecoregions, everything from barren alpine deserts, where you feel like you are on the surface of Mars, to rainforest, montane cloud forests, and invaded dry grasslands in the lowlands. It's a huge, huge range. And so studying climate in a place like this is absolutely fascinating. My first task, the first project I worked on at the University of Hawaii in the geography department was to help develop new maps of mean monthly and annual rainfall for the state of Hawaii. So within the geography department, my advisor, Tom Dembaluka, and the team, we've been working on developing these climate products for a long time. So 2011, we released what was called the Rainfall Atlas of Hawaii. This was an update to a 1986 product and really updated and improved the spatial patterns of what we know of what rainfall looks like in the state. For example, there's a location on the east side of Maui called Big Bog. And Tom Dembaluka put a station out there in the late 1980s. With the old Rainfall Atlas, we thought rainfall out here was around 4,800 millimeters. After having a station there for decades, turns out mean annual rainfall is over 10,000 millimeters, over 400 inches of rain a year. Absolutely insane. And it's likely we do not even know where the wettest spot is in the state, right? But just this was a very important update to understanding what those patterns look like. This is the map of mean annual rainfall that came out of that project. We fused together station data with radar data, meteorological model data to produce what you see here. And a little, Geography 101 style, our islands are located in the trade wind belt, 20 degrees north latitude. You have northeast trade winds that are encountering the mountain slopes and producing wet windward areas and dry leeward areas on the western side of the islands. So we have this very clear windward-leeward pattern. In fact, kids growing up in Hawaii know intuitively the words windward and leeward. They name the car dealerships after windward and leeward. That's how distinct this pattern is. The gradients are extremely steep. In this area of West Maui, over a 6-mile range, your mean annual rainfall goes from 15 inches of rain a year to 366 inches of rain a year. Absolutely insane how steep some of these gradients are. And when you look at the total range of rainfall rates that we have in Hawaii compared to other continents, we've got it, right? We have places with, around 10 inches of rain a year. Central Maui here about 11 inches. Honolulu gets around 25 inches of rain a year. The center of Kauai, known as Mount Waialeale, gets around 393 inches of rain a year. Kids growing up in Hawaii, you can confirm this, grow up hearing that Mount Waialeale is the wettest spot in the world. Turns out it's not even the wettest spot in Hawaii because this big bog site turns out to get a little bit more rainfall, although it's kind of negligible. They're both incredibly wet. So incredible climate diversity across the Hawaiian Islands. And so this project was really important for producing these new rainfall maps. And, in working with the station data, we wanted to not just have maps of the averages, but to create some time series of maps. So using different geostatistical methods, we have created a bunch more time series of gridded rainfall. So in my master's, I developed a time series of monthly rainfall from 1920 to 2012, all at 250 meter resolution, so very high resolution. We followed up on this and created maps of daily rainfall and temperature starting in 1990. And then now we have near real-time daily rainfall and temperature maps available using some machine learning methods from 1990 to present day. So all of these gridded time series for rainfall and temperature allow us to do pixel-based analysis. And where do we house all of these data? How do we make it available? Well, we partnered with the University of Hawaii Cyber Infrastructure team and their data scientists to create a data portal. So the Hawaii Climate Data Portal just launched a few years ago. Our paper came out in 2024. And this is where you can access near real-time climate information. So we have a way to visualize the data with an interactive mapping platform, or if you just want to download it, you can export whatever you like. You can get yesterday's rainfall, yesterday's temperature, last month's, whatever you like, all available in near real time. So you can see they got a lot of windward rain yesterday. We have, in addition to the rainfall and temperature, we have future climate projections that are available here. We've added NDVI maps, fire ignition probability product. We have climatologies, we have drought indices, and we're adding new things constantly. Our most visited website on the Hawaii Climate Data Portal is our cultural resources page. So we actually worked with Native Hawaiian practitioners to develop this page about cultural resources related to climate. And this has become our most popular page on the site, which is incredible. We have a lot of other things and we're constantly adding to it. So this is still a work in progress, but it's already become a really, really important resource. So in terms of, the actual stations that have been measuring the rainfall, that we use those stations to create the maps, the station network has really varied over time in Hawaii. So going back to 1877 on this graph, the number of rain gauges in the state really took off. And with plantation agriculture across Hawaii, they started putting out more and more rain gauges. And in the late 1960s, we had almost 1,000 rain gauges operating at the same time in Hawaii. which is insane. I'm pretty sure the state of Alaska has a solid like 80 climate stations for the whole state of Alaska. So this is a really crazy number. As plantation agriculture declined, the number of stations declined, and we bounced back a little bit. We're at around 400 or so stations now, but you can see what's happening in the map on the left with active stations in red and discontinued stations in gray. We've lost a ton of spatial coverage as far as where we are monitoring rainfall. And when you look at the maps of the other variables, it's way worse. So we have a decent number of temperature stations, but relative humidity, wind speed, and radiation are just severely under monitored across the state. So a lot of my work following up on this was to figure out where we should put more stations. And for years, we have been talking about the importance of monitoring and actually collecting data in the field. And we were able to get NSF, National Science Foundation funding, to install a Hawaii mesonet, a mesoscale meteorological network, a network of climate stations. And we're planning to install around 100. We get the data sent remotely to the Hawaii Climate Data Portal in real time. So that data is immediately being ingested into those maps that you saw in the portal. A lot of work went into just identifying sites and partners and where these stations should go, and I'm happy to answer questions about some of that process. The installation is still ongoing, and we're on the other end building new data dashboards. So the landing page where you access the data, we've been building that up, and it's really awesome looking right now. But we are recording the standard variables, as well as some underground soil moisture, soil temperature, rain, temperature, humidity, wind, all the fun stuff, radiation as well. A look at some of our beautiful stations. We have 76 installed so far. After the Lahaina fires in 2023, we put up a station in Lahaina because there was nothing close by. And then, we're trying to, again, work with that balance of where we need coverage and where we are able to get permission and permits to put up stations. But happy to answer any more questions about that. But this has been just so exciting to be able to expand the monitoring network. We're in conversations with the state legislature to try to get more funding to keep this network going, keep it consistent, which is great. So high hopes that this does not just become, the trash sitting out in the field, but then we can keep it going and keep monitoring these really important climate variables. So that was a lot about sort of the state of the network and averages, but how is rainfall actually changing in the state of Hawaii? So with that data set of monthly graded rainfall, I looked at rainfall trends for 1920 to 2012 and produced these trend maps. So the reds, oranges, and yellows are showing drying trends. Blues are showing places where it's getting wetter. You don't see a lot of blue. Annual maps, annual trends on the top, wet season November to April in the middle, and dry season at the bottom. Any of the trends that are statistically significant are shown in the black hatching. Over 90% of the state has experienced drying over this period. And West Hawaii region, especially in the summer months, has experienced the most severe declines of anywhere else in the state. And I know this ended in 2012, but when we update the data to more recent periods like 1920 to 2019, a 100-year time series, we still see some very strong drying trends in parts of the state. This is in Lahaina, in Maui. So things have been getting drier for a lot of Hawaii. The future of rainfall change is actually very uncertain. Hawaii has been excluded from a lot of products that are available to other places in the US. And so for a while, when it comes to what are the future projections look like from the climate models, we have been kind of stuck with two options, this method or this method. And this is not very helpful for people on the ground who, maybe it'll get a lot wetter, maybe it'll get a lot drier. Yeah, doesn't convey a lot of confidence that the scientists really know what's happening. So we have been struggling with this for a while. We were very loud about this data exclusion during the National Climate Assessment process, and this has actually resulted in some changes and more groups that are working on the US, actually including the full US, and working with Hawaii data. So we're starting to get access to some more projections with the newest set of models that we're trying to work through and process. And so, this is ongoing. But unfortunately, Hawaii is in a location in the middle of the Pacific that's kind of, when you look at the big, broad Pacific maps of rainfall change, there's a line between wetter and drier. And depending on the model, that line is sometimes below Hawaii or above Hawaii. And so all the different models give us uncertainty. The methods to get the global data down to Hawaii local scale give us uncertainty. There's a lot we still don't know. But there's potential for a very dry future in Hawaii. And so in my postdoc work with the Forest Service, we wanted to really understand drought in Hawaii. And I'm sure most of you, when you think about Hawaii, you maybe think of waterfalls or rainforests or these lovely beaches, right? Many people assume that drought's probably not a big deal in Hawaii. You have plenty of water. We're in the ocean, right? You have plenty of water. But drought is a prominent feature of the climate of Hawaii. It is a natural part of the climate, and it has very severe impacts. So how important is drought in Hawaii? Again, a beautiful waterfall picture, but this is what the drought monitor has looked like for Hawaii since the year 2000. Not a lot of drought-free periods statewide, right? Hawaii experiences drought regularly. And last year was a particularly dry year. I know Vermont experienced a very bad drought last year. I think it came out as the second driest year in over 100 years for Hawaii. So also very, very dry in Hawaii, very strong impacts across the state. So similar to how we updated that Rainfall Atlas product, drought had also not been updated since 1991. I basically went through and updated all my PhD advisors from the 80s into present day. But we wanted to know how drought is changing and how drought affects Hawaii. And so this was a paper we published in 2022 looking at a century of drought. And so to do this, we, again, leveraged those gridded time series maps of rainfall and created a drought index, a gridded drought index product all the way back to 1920. So we had 100 years of this standardized precipitation index, or SPI, and this allowed us to analyze drought at every single pixel. And so we looked at different drought metrics, like frequency of drought, severity of drought, spatial extent, et cetera. I guess this, we had done it up to 2019. We now have a real-time version of this available on our Hawaii Climate Data portal. Okay, so what's been happening with drought in Hawaii? Droughts are lasting longer and they've been getting more severe. So from this analysis, the two worst droughts in the last century, this is showing drought over time, 1920 up to 2020. You can see how much more frequently droughts are occurring. And 1998 to 2002 and 2007 to 2014 were the worst droughts that Hawaii has experienced in the last century. If you look at the trends per decade in drought frequency, drought duration, how long they're lasting, and the drought magnitude, all been increasing. And drought duration and magnitude have been increasing significantly over this period. I also wanted to look at the spatial patterns of each drought event, and it's fairly difficult to visualize a multi-year event in one map. So this was my version of trying to do that for these two drought events. So I made these bivariate maps where the size of the point shows you the percent time in drought. So the smallest points were in drought 0% of the time. The largest points were in drought 100% of the time in these years. And then the color is showing you the weighted drought intensity. So least intense drought to most intense. The largest size point in the deepest shade of red was in drought 100% of the time for these periods and was the most severe category of drought. Okay, so you can see different patterns between these two events. This 1998 to 2002 drought didn't really affect the windward side of Hawaii Island, but was very severe on the leeward side. Versus the 2007 to 2014 drought pretty much impacted the entire Big Island for that entire period. Very severe. But for Oahu and Hawaii, the islands in the top left, the 98 to 2002 drought was actually worse. And as part of this paper and some other work, we did a lot of information gathering and lit review and synthesis to understand the impacts of drought in these different sectors. So one of the drivers of drought in Hawaii is El Nino. We know drought impacts farming and ranching, both above ground and below ground water resources. Ecological drought was really interesting. We know we have wildfires associated with drought, tree mortality, impacts on endangered species, and then lots of human dimensions of drought as well. And ecological and socioeconomic are the least studied types of drought for Hawaii. But lots of impacts on revenue losses, on other conflicts, cultural impacts, public health, tourism, all kinds of really interesting impacts that we were able to document here. And so in this work, we were curious about how people are dealing with drought on the ground and how they're making decisions. So we published a report on this, kind of documenting management actions in the region, but it actually led us to a lot more questions about how people are dealing with drought. So what data resources are they using? How are they getting information? What kinds of decisions are they making when it comes to drought? Are they considering drought when they plan new activities? And what kinds of products are most useful for them? So we realized there was a need for a knowledge exchange. So we know that the resource managers we were talking to wanted to be more engaged in research. They had limited time and training to access information. And we needed more formal communication and easier ways for them to get access to comprehensive data and technical assistance. And there's a model for this in Hawaii called the Pacific Fire Exchange. So all of this came together to create the Pacific Drought Knowledge Exchange, or PDKE. And we basically try to get to the managers and the researchers together and talking and co-producing work together. So working collaboratively so we can better prepare for drought across the state. So we use an iterative co-production approach with our partners. We produce a ton of information, training, tools. We are grant funded, and not just from one agency. We've been funded from several agencies. So we like to think of it like this alliance approach. We're going to leverage resources and be the centralized place where all drought things happen. So we launched this in 2019. It's been started with a focus on Hawaii, and we started with these site-specific portfolios. So basically, we piloted this with a couple partners in Hawaii. We start with a management unit. We have access to all this gridded data. We extract the data for those specific sites, and we give them information about their land area. So for Hawaii Volcanoes National Park, what does future temperature change look like? What is their average dry season rainfall in the park or in these different management units? And we pull out all these statistics and visualizations and produce these portfolios. This went through a ton of back and forth to figure out what should be in these. We then automated it and made it through code. So you email someone, they send you a portfolio. Now it is fully automated. You can go to our website, draw whatever area you want in the state, and get your own portfolio sent to you. So feel free to do that. It starts as a PowerPoint that we save as a PDF. It's about 40 pages long now. We're adding more like water things. We've gotten funding from the State of Hawaii Water Commission to add some water resources slides. So it's still adapting, still changing, and has been really useful. Our partners have used this in all different ways. So this has been our starting project. We've expanded a ton since then. We have created this decision support tool for cattle ranchers in Hawaii. It's our Hawaii Rangeland Information Portal. There's a climate dashboard for individual sites where ranches are located. There's a forage growth tool. They can choose their grass type, and based on the El Nino status for the year, we'll look back at the historical data and say, okay, during this phase of El Nino, here's what your likely grass production is going to look like. And so we give them these outlooks based on the historical El Nino relationship. And ranchers were directly involved in development. We went back to them many, many times, meeting with them individually, going to the Cattlemen's Council annual conferences. And so this is also live on our website as well. So in addition to those tools, we've developed a lot of fact sheets with our partners. So some have been site specific. So this is impacts of El Nino on climate in Hawaii Volcanoes National Park. Very specific, just for them. We did other ones with some of our other partners. Some of these fact sheets are statewide. So again, the Commission on Water Resource Management funded us to do these freshwater snapshots for each island. So different spatial scales, different content. We're totally open to doing more of these. And we work with graphic designers to just try to condense information to these 2-pagers. And they've been really useful. We actually worked with a postdoc who translated with her colleagues a bunch of our fact sheets into Olelo, Hawaii. So Native Hawaiian language fact sheets, which have been awesome biocultural resources. And then we do a ton of outreach. We give talks wherever people will listen to us. So it's a lot of local workshops and meetings, smaller conservation conferences and other meetings. We present at national workshops and conferences, done livestock podcast and all kinds of things to just get the word out there and find more partners who want to collaborate with us. We've also been expanding outside of Hawaii and working across the Pacific. We've done work in Guam, in American Samoa, in Palau. If we, when this new grant comes in, we'll be working more in the Commonwealth of the Northern Mariana Islands with some agroforestry information products. So always a lot of fun stuff going on, and we're constantly looking to expand our partners that we work with. So try to keep that brief, but I can obviously expand with whatever questions you have. But hopefully I've convinced you that Hawaii has these extremely diverse climate patterns that present really fun challenges to work on in terms of trying to map them and understand what's happening. Rainfall has been decreasing, droughts have been getting worse with severe impacts across different sectors, and future rainfall is uncertain. But we have lots of awesome tools and products and resources to help inform climate change decision-making and build a more resilient landscape. So before I close, I'm just going to do a quick little plug. So Clark University this year launched a new school of climate, environment, and society. And with that, we have a new master's program in climate and society. So if anyone's looking at grad programs, we have a bunch of them, a whole bunch of graduate degree programs. This is myself and the new dean of our school at the United Nations COP meeting in Brazil this fall. So we're trying to figure out how to make that a more regular thing and go to these COP meetings. But if you have any questions about these, just let me know. Thank you.
I should some simple water.
Yeah, I'm talking all day.
You know some of the applications people have done based on your work?
Yeah, that is a fantastic question. And our team has actually been talking about how we need to do a better job of writing these things down. But with Hawaii Volcanoes National Park, for example, they used the products from the portfolio to actually inform where they were going to do new outplanting of endangered species. So they basically used the climate information, the future climate information, to say, okay, historically this plant grew here, but in a future climate, it's probably going to do best at surviving over here. So they've actually shifted and chosen their planting locations based on the data. We had another group who used the portfolio to give them specific information for funding proposals that they wrote. And we've had, I'm trying to remember some of the other examples, but it's definitely been used a lot, but we need to do a better job of writing it down, and that's what we're going to try to work on. Yeah, great question. Yes.
Is the research from the research and data across the islands, is it ever used for like interpolation on other islands, or do you kind of treat all 8 islands as their own sort of?
Yeah, so within Hawaii, we're usually there's usually enough stations that we can interpolate each on their own. sometimes for Maui Nui, like Lanai and Molokai don't quite have enough stations. So I remember with some of our work, we did have to group those together. So yeah, most of the time we can do them on their own, but sometimes we do have to kind of pull from information from those closer islands. And we're doing some new mapping in Guam and American Samoa now too, which is exciting. Yes.
I was wondering what caused that decrease in the rain gauge stations, and how can you like avoid that from happening in the future?
Yeah, so a lot of the decline was because of the decline in plantation agriculture. So there are actually no more active plantations in Hawaii. So it used to be sugarcane and pineapple took up huge parts of our landscape. Those have gone away, which means they're not monitoring those spots anymore. Granted, some of those stations were kind of redundant from a statewide scale, maybe. And you know, we need to do a better job of locating sites up in more remote locations. But you know, trying to centralize it and relay the importance of monitoring and how much we really need these long-term records is so important. And with some of our new mesonet sites, we're actually trying to put them at the same location as an old discontinued gauge. So then we could continue the record from the historical record. So we're trying. Monitoring is not that exciting. People don't love to pay for it. So finding the funding to keep these things going, you know, everyone understands how important the data are. They just maybe don't want to pay for it all. So we're trying to like get a ton of partners from across different agencies so we can keep that support going.
Yeah.
Have you looked into monitoring or just placing some sort of SST sensors out to see kind of the transition between your patterns of, because I know you have like the general like satellite imagery that gives sea surface temperature, but is there any consideration to do real-time observation of the SSTs?
So all of my work has pretty much been terrestrial. There are a lot of ocean buoys that are monitoring sea surface temperature conditions, and there's an Aloha buoy that's close by, and I think that's where a lot of the data come from. But yeah, that starts to transition into someone else's domain and like the nearshore ocean folks. But there's a ton of ocean and coastal research going on as well. So yeah, people are monitoring, especially sea level, sea surface temperature, but sea levels are closely monitored. There's a coastal geomorphology group who does a lot of imagery of the coastlines and does a ton of modeling of what sea level rise is going to look like for the islands. Yeah.
This is really awesome. Thanks for
Okay.
I'm curious about what led you to choose a 250-meter spatial resolution? Like, was that operational or was that data availability?
It was data availability. It was sort of, that felt like the right resolution based on the size of the station network that we were working with. And then we've tried to make all of our future products match that same resolution. So when it comes to things like temperature, these other variables, we don't have the same great data coverage. You know, there's definitely more interpolation happening there. But the methods to make the temperature maps are quite different from what we've used for rainfall to accommodate that. We have very few temperature stations at the high elevations, which with the few stations we do have, we've seen stronger warming trends at high elevations than low elevations. So it's yeah, there's definitely a understand the data source and the limitations going forward. But yeah, it was based on the data network we had. Yeah.
I have some online questions.
Great.
So what can we do as people living in Vermont to help raise awareness about Hawaii's drought crisis?
Ooh, great question. I mean, we do have some social media that we post on our Instagram page, and I think, I can't remember what their other one is. This is the main one that I follow, but I think, you know, we are starting to see more awareness. Unfortunately, it's been past crises that have happened that have led to awareness that Hawaii has drought and fire issues. And I think, unfortunately, a lot of the, you know, aside from getting national resources to get us more products and build equity and get us, you know, the same products everyone else has access to, I think a lot of it comes down to what's happening locally and its local government initiatives. So yeah, I'm not sure as far as, yeah, what kinds of things can be done on that end. But, I think if people ever visit Hawaii to, just make yourself aware of some of these issues and what's happening, and, to be a conscious traveler and try to take in some of this stuff, and conserving water is
One more.
yeah, of course.
Okay, where in the islands do you see the most need for stations? And have any communities, example, cattle farmers on Oahu, specifically requested a local station?
Oh my gosh, we have gotten so many requests from people for stations, and it's been from all different communities. So I would say some of our biggest needs are the more remote, hard to access locations up in the mountains, where we have these really steep gradients and steep transitions. We need denser station networks to really capture that. So that can be really difficult. We have a lot of the ranchers do their own monitoring, actually. So some of the ranchers had rain gauges and data going back a long time that we had never seen because they keep it to themselves. So, making building partnerships and trust with different community members has been really important. There's this one woman on Maui, I think she's in Hawaiian Homelands kind of landscape. So yeah, Native Hawaiian community. She's got a big queue on her roof, like so excited about the Mesonet station in her neighborhood. So excited. So it's this really, people are excited for the data, and we love to see it, and they want to support and they want to help. And honestly, I think there's more demand for stations than we have money and equipment to actually put out there. So it's been a balance, but we love the enthusiasm. Yeah. Yes.
Has there been any previous or potential for restoring one of the old climate stations rather than installing a completely new one, or are they too old at this point?
It's more that they don't exist. Like someone took the rain gauge was there and they took it away. So it's more like figuring out the exact location. I shared over lunch some of my struggles by figuring out coordinates of old stations. A long time. So it's figuring out where those sites were, is it viable? Do we need a station there? And then do we have permits and contact with the landowner to permission to put a station back there? So there'd be a gap, but it could be a cool, long-term extension of an old station. Yeah.
I'm curious about the human vulnerability side of things, who in Hawaii is most affected by droughts?
Yeah, that's a great question. I would say some of the folks who are first affected are the people who are on water catchment systems. So a lot of people in the more rural areas of Hawaii, especially on the Big Island, they use rainwater for their drinking water. They have a catchment tank in their yard, and they have to purchase water from these private water haulers when there's a bad drought. And we've talked about this for the last couple of years, and we still don't have a good way to get the data on how much money is spent buying private water when there's a drought. We don't actually know. We know how many residents are on water catchment. It's in the tens of thousands, but we don't know how much is being spent during these droughts. So that's, I would say that's a big gap. So those folks very immediately affected. And then it's farming and ranching also feel the effects right away. And it was really interesting this year with the drought. We were hearing from the ranchers that they had to, so to fight fires, sorry, back of the step. To fight fires upland, we use these big reservoirs as these dip tanks for the helicopters. So the helicopters will come and they'll fill up their little thing and they'll fly over and they'll dump the water on the fire. A lot of those dip tanks are on private lands, like the ranching lands. So the ranchers had to go buy water to make sure that firefighting dip tank was filled up. Because if there was a fire on their land, they wanted it dealt with, but they were the ones footing the bill for paying for this water to fill up those tanks. And so who should be paying for that? And, really, really interesting questions. Yeah. Yes.
You had a slide, I'm asking this question because I'm going to introduce some of this in my class later this semester. Early on, you had a slide where you mentioned using machine learning to create some of your products. I'm wondering if you could just briefly summarize what that looked like and using simple language for the undergrad.
Yeah. So it was actually one of our analysts who led that part of it. So what we were using, often for our rainfall maps, we've used creeking methods. It's a geostatistical interpolation method. Basically assumes that places next to each other are more similar than places further away. And so you have to fit, it's called a variogram to that model, to that relationship. So what we used is an optimized creeking method. And I'm pretty sure where the machine learning comes in is it's fitting that for us, as opposed to us like manually making sure it all looks okay. There's probably some other details there, but we published a paper in 2022 if anyone wants to read up more on that. But it's an optimized creeking that is having the computer figure that out for us. Yeah. Other questions? Yeah.
A little more of a general Hawaii question.
Yeah, love it.
How much is government awareness of these recent droughts, just like not just like this year, but like in I don't know, past a decade or two? How much does that influence the public policy of water usage and limitations?
That's a really interesting question because across the state, right, the capital is in Honolulu, most of the people live in Honolulu. They've been experiencing very different kinds of water conditions compared to Maui and the Big Island. And, we saw from some of those maps, like the more recent decade, like Maui and Big Island were hit crazy hard by those recent droughts. Well, everyone on Oahu was able to turn on their taps and the water came on and they didn't think about it, right? So there's a big disconnect, I think, from some of the more rural areas in the state compared to the urban areas when it comes to water. So I think, at the county level, I think there's much more awareness about water restrictions and conservation, and they'll put into effect these water crisis levels and things. But statewide, I don't, the water is managed. We have individual board of water supplies on each county, and then there's a statewide water commission that sets like low flow standards in the streams and helps figure out if we have enough water to like approve a new development of a high-rise condo or something. So they're definitely aware that like water is precious. It's ingrained, I think, in Hawaii. People, water is life. There's tons of our sayings like in Hawaiian, I think to say that someone is rich is like bye, it's water. Like it's equated with being wealthy and like having resources is water. So it's very ingrained there. But I'd say there's a lot of tension with development and water and other natural resources. So I don't know how much more I can say on that, but they're aware. It's just there are definitely pressures with development.
I think for your site-specific for portfolios, what do you have a specific target audience in mind for those, or what do you do to decide what information you want to put in those?
That is an awesome question. So we started with natural resource managers in, like ecosystem managers. So it was very much, their perspectives of what they wanted. We've kind of been following sort of where the money has come in terms of our grants and who we're working with. So we've started to expand to other sectors and working with other folks who are interested in different metrics. And so as we work with new people who say, this is missing for me, we add it in. We figure out what they want and we adjust. There's some basic stuff in there for everyone. And then there's probably some custom things that maybe only some people care about depending on their answer. But we're really adaptive and we try to make sure that, we're meeting the needs of whoever wants to use the data.
Okay.
Yeah, great question. These are great questions. This is fun. Any others? Yeah.
I think for you talked about how the Dark Out site had been axed last summer. Has like funding of just general operations of your work kind of hit any difficulties due to the current times?
Absolutely. So I personally have had a USAID grant that was terminated right away last year. We were updating climate risk information sheets for different countries around the world, and we had made a bunch of them, and the students were leading it and making these awesome maps, and all done, and then they disappeared. That was very sad. I also was part of an NSF project on water resources in Mexico City. It's a very cool project integrating water modeling and on the ground co-production, social, understanding of water issues with communities. We were also 3D printing weather stations, and we bought a 3D printer for our partners at UNAM in Mexico City, and they're running with it. They 3D printed weather stations, they put them up in communities, people are gathering their own weather data. It's incredible. Last year. I don't know where that one stands. They actually filmed us for an AGU TV video this year about our Mexico City project. I might be wearing the same shirt. And then actually just in December when they announced that they were kind of coming after the National Center for Atmospheric Research, NCAR, one of our drought projects from NIDIS was run through UCAR, and they said, nah, that seems like it's too people. Like, I don't know. I can't remember the exact wording, but that one got canceled 6 months before it was supposed to. So, yes, we're definitely being impacted. That's funding our staff who are doing this work. And, we're still trying to figure this out. I also work a lot with other federal agencies like the Climate Adaptation Science Centers. And the Pacific Islands Climate Adaptation Science Center, they were supposed to do their rebid last year, and they just said, no, we're not going to hear any rebids. So for this last year, PICASC exists in name, but they have no budget. And when that 1 year ends, they might just completely disappear. They might let them go for the rebid. No one really knows what's happening, but a bunch of my colleagues, this has been a huge funder of our work, might be gone. Don't know. So yeah, realities of this right now are very rough. And we're trying to find other sources that are more stable and allow us to do this work and keep supporting it. NIDIS, the National Integrated Drought Information System, they should be getting their budget. Drought tends to be more nonpartisan, right? It affects people in all color states, right? So, people care about drought, and it can be framed in ways that are different from climate change. I don't know. However you want to frame it. Drought money can be a little bit more secure, but who knows? They may change their minds. But anyway, if they get their budget, we should have a grant coming in to support some of our staff to keep working on some of the stuff we're doing. A great question. Yeah, I was supposed to be an author on the 6th National Climate Assessment and was let go last spring from that. They released us all from our duties for that. And no one knows what the next National Climate Assessment will look like because they're mandated to produce one. Will it use credible science and a robust review process? We're not sure. Anyway, sorry. I dabbled in other things plenty. Okay.
I have one more for you, but I want to see if anyone else. One of the things that we've been trying to do with this series this semester with alumni is just, sort of build the reputation of UVM as a place of producing really excellent people out there doing work in the water world. But my question sort of flips that on its head. If you were to think back to your experience here as an undergraduate and give advice to your younger self, do you have any advice for our students here who might sort of aspire to kind of work in some way in the realm that you're working in?
Yeah, I mean, I was telling a few of the students at lunch, I was so extremely grateful that I had been forced to take a computer science course in my undergrad. It has come in so handy. I mean, we are in an era of big data, and in order to manipulate the data and do what you need to do, you have to be able to code. Take some kind of computer science class. Python seems to be where everything's heading, but just understand basics and you can teach yourself anything, I would say. I mean, stay in touch with your UVM professors. They are fantastic resources and can really help connect you. And they're here to help you and help you get out there and find what you're passionate about and do awesome work. Explore classes, figure out what you like. I stumbled into this field really late in my undergrad and I wish I had found it sooner. There were a whole bunch of classes I wish I could have taken, but I don't know. I'd say those are probably some of my takeaways. Yeah.
So how late in your undergrad did you run into this and find out that you wanted to do this?
It wasn't until my junior year. Yep. I had been doing the math major and I enjoyed it, but I just didn't know where it was heading for me. And as soon as I took weather and climate and GIS, I was hooked. I love being able to explain why things were happening out in the world, and it all just clicked and made sense. And I just loved it. And the fact that I could actually major in this and something that was such an awesome fit for me, I just lean into that, right? If you find something you really like, lean into it. Yeah. So late, junior year and the winter break. Travel courses helped me graduate on time.
Okay, last call.
Feel free to email me anytime. Yeah.
Okay, we have an end of seminar presentation for you. The Alumni Association dropped off gift bags for all of our speakers.
Awesome.
So this started with an Alumni Association gift, and we've added to it from the Water Resources Institute.
Thank you so
Things
much.
to take home.
I love it. Thank you.
Let's thank Abby for a fun talk.